So today we're going to use a matrix method to solve for two unknowns in a simultaneous equation. So if you don't know what a simultaneous equation looks like, it's two or more equations with unknown variables. So if you look at these two here, this is the first equation. We know it's an equation because we have an expression here and we have the equal sign here. The equal sign is what makes it an equation. So then we have a second equation here. So basically what makes these equations is because we see that we have algebraic expressions with an equal sign inside of them. So these equal signs make these algebraic equations. We're going to look at the steps that we need in order to solve this. We're going to use the same example to actually work it out. So I'm going to do it in phases so you can see each phase. So theoretically, the first thing we have to do is we have to write the simultaneous equation in the form AX is equal to B, where A, X, and B are matrices. So the X would represent the unknown, which we will see when we work on an example. Number two, we then have to determine the inverse of matrix A. So from this expression here, we have to determine the inverse of matrix A. Now, once we have the inverse, in our third step, we'll multiply that inverse to B so we can solve for X. And we are solving for X in that instance in order to determine the values of X and Y. So let's break this example down and try to answer it so you could understand what's happening here. So first things first, we want to write the equation in the form AX is equal to B, where A, X, and B are matrices. So that's our first part, so part A. So the first thing I'm going to write is matrix A. So matrix A, we're going to get it from this simultaneous equation. So if you look at it here, we have to take the coefficient, so the numbers in front of the variables. So in this case, we have 5. In this case, what do we have? We have a 3. But not only do we have a 3, it's a positive 3 because of this plus sign. We can say this is positive 3. Now down here, we're going to have 4, and it's positive. We don't see any minus sign on it. And here we have a 2, but it's not just a 2. It's a negative 2. So looking at this here now, that's our first matrix A. So this A is going to be 5 here, positive 3, 4, and negative 2. So notice what I did here. All I have is the 5 here, which is this 5, the 3, which is this 3, the 4, which represents this 4, and the minus 2, which is here. Now, the part that represents the X is just going to be the unknown variables. So in this case, the unknown variables we have, the first one we have is X, and the second one we have is Y. Now our final matrix that we need is B. So we're saying here that B is these last two numbers here, 9 and 16. So for B here, you would have 9 at the top and 16 right here. So now we can write the equation in the form A times X equal B. So if I'm writing it in the form AX is equal to B, I'll write the A next to the X. So in this case, I'll have 5, 3, 4, negative 2, which represents the A, and then next to it I'll have the X, which is just going to be XY, and then I'll have here is equal to 9, 16. So 9 and 16, this is A, this is X, which is equal to B. I just wrote this simultaneous equation in the form AX is equal to B. So if you're curious and you want to know why we write it this way, this is literally the same as this, okay? So if we're multiplying matrices, how we usually go is we try to make sure that they are conformable. So in other words, how many columns and rows does this have? This has 2 rows by 1, 2 columns. And we have to try to multiply it to this one here, which has 2 rows and 1 column. So once we see that these here are the same, so in other words, this was row times column, this here was row times column. Once we have this, the number of columns in the first matrix is equal to the number of rows in the second matrix, we know that they are conformable and we can multiply them together. This is something we learned in our first video in relation to matrices. So this here is just for those of you who want to understand how this is the same as this. If you're not interested in that part, you can just skip forward to the next phase. So now that we know they're conformable, you can go this way and this way to multiply. So I'll say 5 times X, which is 5X, plus 3 times Y, which is 3Y, and that's equal to what? 9. Then I could have 4 times X is 4X, plus minus 2 times Y, which is minus 2Y. Now plus minus 2Y is the same as saying minus 2Y, which is equal to what? That's equal to 16. So essentially, writing a matrix like this is the same as having it written like a simultaneous equation here. This is how we can convert this here now, how we just did earlier, into this form. Alright, so part B. So part B, we need to determine the inverse of a matrix A. So just in case you never did the inverse of a matrix, we also did that before in our previous video on determining the inverse. So you can always look back at that. But just in case you don't remember or don't know, this is how we go about doing it. So this is matrix A, which is 5, 3, 4, -2. Now we say in order to find the inverse of a matrix that would be the same as A to the power -1, we have to find 1 over the determinant of A, and we have to multiply that to the adjoint of A. We always try to find a determinant first so we don't mix up the adjoint of A with A and get the wrong determinant. So we always try to find the determinant first. So the determinant of A would be equal to the crisscross, like I like to call it. So 5 times -2. Notice my brackets, so I'm careful with my signs. Minus 3 times 4. Brackets again, 3 times 4. So then in this case, I'll have 5 times -2 is -10. Take away 3 times 4, which is 12. So in this case, -10 take away 12 is -22. So my determinant is -22. Now for my adjoint, we swap the 5 and the -2. So we always swap these two here. So -2 will go here and 5 will go over here. And we change the signs of these two here. So if it was 3, it's going to turn to -3. And this 4 is going to turn to what? -4. So now that we have the determinant and the adjoint, we can write that the inverse 1 over the determinant. What's the determinant? -22. And we put that next to the adjoint, which is -2, -3, -4, and +5. So our inverse is this. So now we have part C, where we actually solve for what x and y is. So now in order to find the value of x and y, we have to multiply the inverse of A to B. So we know that here represents x and y, which is what we're trying to find, which is equal to the inverse of A, which is 1 over -22. Then we have our numbers here on the side, -2, -3, -4, 5. And we're going to multiply that now to B. What is B? 9, 16. So now when I work this out, I should get my answers for x and y. So I'll just create a little bit of space here. Alright, so how I like to do this is I like to try and multiply these out. I like to try and multiply these out first, and then I'll deal with this. Okay, so we go back like this again. So xy is equal to 1 over -22. So I'm worried about this here first. That's the first thing I'm going to do. So I'm going to go, remember we have to go across like this and then down. There's going to be -2 times 9 plus -3 times 16. Now notice how we go like this times this plus this times this. Okay, so then we'll have here now -3 times 16. So the same concept will go for the bottom. So we'll do the -4. What do you think we're going to multiply it by? The 9. So -4 times 9 plus 5, this 5 here, multiplied by 16. So -2 times 9 is -18 plus -3 times 16. -3 times 16 would give us a -48. -4 times 9 would give us, since a negative times a positive is a negative, we'll get -36. And here, 5 times 16 should give us 80. So in essence, we will have here xy is equal to 1 over -22. Then inside here, we'll have -18 plus -48. And then we'll have -36 plus 80. When we simplify that, we'll end up with 1 over -22. -18 plus -48 is -66. And then -36 plus 80 would give us +44. So that's what we're going to get right now. Now that we have that, we could do the last step, which is going to give us 1 over -22 multiplied to each of these numbers. So what we will have is 1 over -22 times -66, and then we'll have 1 over -22 times 44. What we have here is the same thing as saying -66 over 1 and 44 over 1. So if you look at this, this is the same as saying -66 divided by negative 22. So a negative divided by a negative is a positive. So 66 divided by 22 would give us 3. And then 44 divided by negative 22. So a positive divided by a negative would give us a negative. So 44 divided by negative 22 is negative 2. Therefore, we are saying that x is equal to 3 and y is equal to negative 2. Now, to prove this answer, we could try it in the formula. So what we have here is x would be 3, y would be negative 2. So what we are saying in essence is 5 times 3 plus 3 times negative 2. So what's 5 times 3? 5 times 3 is 15 plus 3 times negative 2 is negative 6. So 15 plus negative 6 gives us 9. So let's try it for the next equation. As you can see, we have 9 here. So we could say 4 times 3. So this here again would be 3, and this y would be negative 2. So therefore, we can say 4 times 3 take away 2 times negative 2. What we have is 4 times 3 is 12. Take away 2 times negative 2 is negative 4. So 12 take away negative 4 gives us 12 plus 4. Because of these two negatives, we get a positive, which is equal to 16. So we know that this here is correct. Now we're going to try one more example just so we can see everything come together. So instead of having the steps line out this time, we're going to go straight into it and solve the question. So therefore, we have to answer we have to complete all these steps in order to figure out the answer. Okay, so remember, the first thing that we need to do is write the matrix in the form AX is equal to B. Remember the last time we looked at the coefficients? So the first thing we have here is minus 4. Now I intentionally put this question here because this is one that gets people confused at times. So if you look at this y, there isn't a number here, but technically this number here is 1 because 1 times anything is itself, so there was no point in putting back the 1. Likewise, if we had minus y, we would know that the coefficient was minus 1y. So this is something to bear in mind when doing questions like this. So the next one we have is, we have a 6 here, and over here we have a minus 5. So we know that we can write a as negative 4, positive 1, then 6 minus 5. So in other words, this negative 4, positive 1, 6, negative 5 represents our matrix A. Now the matrix X, we said that that would be XY, which is equal to what? Our B in this case, which is negative 11 and 27. So we did our first step, which is get it in the form AX is equal to B. This is A times X, which is equal to B. Now, the next step is find the inverse of A. So the inverse of A. What you start to notice is that doing this is a repetitive step. It does the same thing over and over. Once you get the steps down pat, you'll be able to answer any question like this. So when we get the inverse of any 2 by 2 matrix, we have to get 1 over the what? The determinant, and we have to multiply that to the adjoint of that matrix. So the determinant of A. So this here is A. You know what we do? The crisscross. So negative 4 times negative 5. So A would be equal to negative 4 times negative 5. Take away 1 times 6. So we have negative 4 times negative 5. Take away 1 times 6. So negative 4 take away negative 5 is positive 20, because a negative times a negative is a positive. Minus 6 gives us 14. So the determinant is 14. Now the adjoint of A, remember for the adjoint, we swap these two numbers here. So then negative 5 comes here and negative 4 comes here, but we change the signs of this. So 1 turns to negative 1 and the 6 turns to negative 6. So when we combine this, we would have that the inverse is equal to 1 over the determinant, which is 14, and then we put that next to the adjoint, which is negative 5, negative 1, negative 6, negative 4. So we completed that step. So our last step now, we want to get it like x is equal to A inverse multiplied by B. So we know that xy would be equal to 1 over 14, negative 5, negative 1, negative 6, negative 4, which we are multiplying that to negative 11 and 27. So you know what I'd like to do first? I'd like to multiply these first and deal with the fractions after. So remember what we said? We always go from left to right and then down. So therefore, I'll have negative 5 times negative 11, and I'll be adding that to negative 1 times 27. So negative 1 times 27. Next phase, negative 6 times negative 11. So negative 6 times negative 11. Notice how I'm moving across for this, but coming down for this. And I'm going to add that to negative 4 times 27. So negative 4 times 27. All right. So I'll have back my 1 over 14 here. So I know that negative times a negative is a positive. So therefore, negative 5 times negative 11 is positive 55. And I have to add that to negative 1 plus 27, which is negative 27. Over here, I have negative 6 times negative 11, which is positive 66, because a negative times a negative is a positive. And then here now, we have negative 4 times positive 27, which is going to give me a negative value. And that's going to equal to negative 108. So I have here 55 plus negative 27, and then I have 66 plus negative 108. So if I simplify that, I'm saying I have 1 over 14 multiplied by 55 plus negative 27 is 28, and then I have 66 plus negative 108, which is negative 42. So remember what we said here now. This is the same as saying 1 over 14 times 28, and then 1 over 14 times negative 42. This is the same thing as saying 28 divided by 14, which will give us our value for x, and negative 42 divided by 14, which gives us a value for y. So in that case, we can say that x is equal to 2, because 28 divided by 14 is 2, and y is equal to negative 42 divided by 14, which is negative 3. So our answer, x is equal to 2, and y is equal to negative 3. And if we put this into this formula, we will get the answer. So I know that this here is quite a bit of work, but as you can see, we completed the 3 steps that we need in order to solve this. We put it in the form ax is equal to b, we find the inverse of a, and then we multiply the inverse of a by b to get our unknown variables. Hopefully this makes sense. Just go over it as many times as you need to in order for it to stick. All the best, and continue to practice for your exams. Remember, this ain't no play man thing. This is serious business.